Good afternoon. My name is Jimenez. I'm a PhD candidate at UC Santa Cruz. And today we're going to talk about experimentation protocol that we've developed in a CLI tool. We name it Popper for the philosopher Karl Popper. And to motivate why we need an experimentation tool or experimentation protocol, let me go over a scenario that I'm sure most of you have gone, which is we're reading a paper. We get to the experimentation section and we come up with questions like very practical questions like how was something compiled, what are the flags that were passed to certain binaries, how are subsystems configured, and so on. Some questions that we cannot necessarily answer by just reading a tech report or a paper. So if we reflect in this scenario and we compare with what people have in other domains of empirical sciences, we see that we could benefit from having the analogy of a lab notebook, right? Which is a written record of what has been done over time and why, and just documented over time. And if you've used version control systems, you could picture having using a version control system as the lab notebook, as the electronic lab notebook. The problem is that by putting everything on a version control system doesn't make it automatically reproducible. And what we want to have is to make it very easy for others to re-execute what you've done. So to that, with that goal, we took a step back and we kind of like systematically try to abstract what we do when we implement a scientific exploration. And basically, we have a very generic pipeline. Which at each of these stages of a pipeline, we might have like code associated with it, data sets, documentation, and so on and so forth, even like manuscripts, tech reports. So if we compare this to what people do in industry, what people do in open source software development and DevOps communities and software engineering in general, we kind of like see a one-to-one mapping correspondence between what we do as scientists when we're exploring a new scientific question and what they do. So the key idea behind the protocol and the CLI tool is why don't we just manage a scientific exploration as if it was a software project. So that's the idea, and if we then map what people use in practice, there's a lot of tooling. This is just a small sample of what you find out there. There's a lot of very mature tools, very well-documented tools with big communities, and we could just leverage that. And that's basically what the Popper convention is. It's very simple. There's nothing much new here. It's just three simple guidelines, which is picking one or more of these tools, writing scripts for those when we're implementing our pipelines, and putting everything on version control and document as we go. And then if we do that, we end up with what we call, what we refer to as Popper compliant experiments. And in order to make it easier for others to follow that convention, we have a CLI tool. And the CLI tool allows you to have some very common structure on a Git or a Mercurial or any other version control repo, and that it's easier for others to understand, and we basically they are self-contained. Everything you need to re-execute an experimentation pipeline is there. You just git clone and then execute, and it should run. We have been recently working on some archiving features so that you can basically have a GitHub repo and very easily get a DOI on Zenodo or Fixture or something else. And we also have some very easy to use facilities so that you can basically continuously integrate your pipelines. So that you generate CI configuration files that you put in your repo, and then you connect with existing services like Travis, and those things allow you to just continuously, every time you make a change, you can rerun a pipeline and have everything end-to-end automated. And I have a poster. Please stop by if you are interested in these issues of reproducibility. Thank you.